Okay, we're going to do a sequence problem. How many terms must be added in an arithmetic sequence whose first term is 78 and whose common difference is -4 to obtain a sum of 702? So let's do a little reminder on arithmetic sequences. There's a couple of formulas we like to have handy. We know that the formula for an arithmetic sequence, there's two formulas really. There's the nth term of the sequence, and then there's the sum of the sequence, and we're actually going to use both in this problem. So the nth term of a sequence in general can be said to be a sub n, so that's the nth term, equals, in general, c, the common difference, times n, the number of the term, plus some integer number, some constant number, which we'll call d in this case. So Cn plus d is the nth term of an arithmetic sequence. And then the sum of the sequence we'll call Sn. So this is the sum of n terms. So if s was 3, this is the sum of the first 3 terms. If s is 10, it's the sum of the first 10 terms, and so on. So Sn is equal to n times a1, the first term, plus an, the nth term, divided by 2. And there's an intuitive reason for this, and maybe we'll go over it, but if you have these two formulas handy, that's a great starting point. So we want to know how many terms of this sequence we need in order for the sum to be 702. So basically, we want the sum, this formula, to equal 702. And we want to know how many terms it takes to do that. So basically, we want to solve for n. So if we're going to solve for n, we need to know a1 and an. Well, we already know a1, right? a1 is 78. So a1 is 78. So how can we use that? We can plug that directly in here. So this is known. An, on the other hand, is the nth term for whatever n is, and n is what we want. So an depends on what n is. N is the answer. So if we can re-express an in terms of n, we can substitute that in here. And that's exactly what this formula does. So if we can take this explicit expression for a sub n and substitute it in here, then we'll have this equation equals 702. The only thing we won't know is n, and we can solve for it. So let's go through that. How would we actually express a sub n? Well, we know the first term is 78, so a1 equals 78, which equals the common difference, they told us is -4, times n. We know n is 1 because we're talking about the first term, plus d. We don't know d, so we have to find that out. So this we can do. 78 equals -4 plus d. So d must be, so this implies that d must be 82. Okay, so now we know the expression for a sub n. We can say a sub n equals -4 n plus 82. Now, we can substitute that in here, as we were saying before, in order to solve for n. So let's go ahead and do that. S sub n, which needs to be 702, sorry, equals n, which is what we want, times a1 that we know, 78, plus a sub n, which we just determined, -4n plus 82. -4n plus 82. And that's all over 2. Okay, now let's simplify this algebraically a bit. In here we can do 78 plus 82 is 160, so we now have n times 160 minus 4n all over 2, which is 160n minus 4n squared over 2, which we can actually divide by 2, so that would be 80n. I might run out of space here. I'm going to run out of space. Let me go down. 80n minus 2n squared. And this is equal to 702. Sorry, I haven't been writing that the whole way along. But now it looks like we have a quadratic equation on our hands, right? So we should get everything on one side and set it equal to 0. So let's add the 2n squared over and subtract the 80 over, and we'll get 0 equals 2n squared minus 80n equals, plus 702. And why don't we just go ahead and divide everything by 2? So this will become 0 equals n squared minus 40n plus 351. And by the way, it's okay to do that, right? Because we're dividing by 2 on the right, but we're also dividing by 2 on the left. So 0 over 2 is 0. That's fine. This we can now factor. We can probably factor it. I don't know how to factor it off the top of my head, so I'm just going to do quadratic formula. So negative b plus or minus square root of b squared minus 4ac over 2a. So that's 40 plus or minus b squared is 1600, 40 squared, right? Minus 4ac. 4 times a is 1, so I don't need to do that, times c is 351, and that's all over 2a, and a is 1, so that's just 2. 4 times 351 is 1404, so 1600 minus 1404 is 196, and the square root of 196 is 14, so this whole thing boils down to 40 plus or minus 14 over 2, which means it could be either 54 over 2, which is 27. Well, let's write this out. So 54 over 2, or minus 14 is 26 over 2. So we have two answers, 27 and 13. And I think that's it. So, but the question is, why are there two answers? And let's think about this sequence. What we're saying is that it's as n gets bigger, the term that's negative gets bigger. So what eventually happens is that as n gets larger, the terms a sub n become smaller and smaller. So eventually the arithmetic sum of the sequence is working against itself. It's increasing and increasing and increasing with as n gets larger and larger up until a certain point. Specifically, the 21st term is the first term that's going to be negative, right? If you plug in 21 here, you'll get negative 84 plus 82 is negative 2. So now all of a sudden, with every new term that you add, the sum is actually getting smaller and smaller. So what probably happens is that this thing passes through, the 13th term makes it true, and then it gets bigger and bigger for a while, and then it starts getting smaller, and later it passes 702 again. So it reaches 702 twice along the way. And we can prove this by plugging back in. I'm going to erase some of this stuff from up here and just do a quick test on this. I'll keep the answers there at the bottom. We don't need all this. So we think the answers are 27 and 13. Let's write that over here. Now let's test. What would S13 be? S13 would be 13 times A1, which is 78, plus A sub 13, which we don't know, over 2. But what's A13? A13 is given by this guy. Minus 4 times 13 is, plus 82, is negative 52 plus 82, which is 30. So we can plug that in up here. So 13 times 78 plus 30 over 2 is 13 times 108 over 2. I'm going to jump down here. Sorry about that. 13 times 108 over 2 is 13 times 54, which is 702. So that works. And we can also prove that 27 works. S27 equals 27 times 78 minus A27, which we don't know, over 2. What's A27? We go back again to the A sub n formula. Minus 4n, so minus 4 times 27 plus 82. 4 times 27 is 108. Negative 108 plus 82 is going to be 26. Sorry, negative 26. So that's what needs to get plugged in here. Oh, this should be a plus sign. 78 plus A27. But since, yeah, I was thinking ahead. So since A27 is negative 26, it actually gets subtracted. And this becomes 27 times 78 minus 26 over 2, which is 27 times 52 over 2, which is 27 times 26, which is 702. And that works as well.